Hi, I'm Lawrence, and this is our Capstone CSE 485 interim presentation, where we want to design and implement a secure IoT network based on a project collaboration application. The members in this group are Emanuel Boderash, James Hutchins, Laurence Chang, and Ngoc Nguyen. So this is just an agenda of what this presentation is going to include. First, we're going to talk about our motivation as to why we want to implement this secure IoT network. So our project objectives, what we're going to try to do. Then we're going to go into the introduction of general IoT and IoT security background. Then we're going to focus a majority of our time on the methodology, the actual implementation process, what process we're going to take, what strategies we're going to take. Then we're going to dive more into the background stuff, so the project roles, the timelines and deliverables, what we should have done by when, the current project progress, and then we're going to end it with the references. So the project objective, like I said in the beginning, we want to implement and design a secure IoT network. We want to expand this by starting off with a use case scenario. So we're going to use an application, a smartphone application, as the catalyst for all this. So this application is going to be a simple project collaboration management app for smartwatches and smartphones, our IoT devices. And then after we get that finished, we're going to start integrating the IoT network, and as our main focus, we want to make sure these devices communicate with the server the way they're supposed to. We want to make sure nobody can get in between these communications, and nobody can use these applications that we create to take control of the device. So you can see here the nodes in our IoT network are going to be the smartphones and the smartwatches. And one of our main objectives is to cover all the security objectives that we've learned in any cybersecurity class, which is confidentiality, integrity, availability, and authenticity. So some introduction and background. IoT is a largely growing paradigm, and the number of devices are projected to increase by maybe 2 to 10-fold in the next couple of years. So why is this a concern? Well, the number of devices also creates a larger surface of attack for people with malicious intent to mess around with people's devices or perhaps the network itself. This is shown in some recent news, including the CCTV cameras botnet, or even last week on October 21st, where half of the East Coast sites were inaccessible due to a DDoS performed by these IoT devices. So, given all this, we want to give a guideline or a demonstration of what a secure IoT design might be, how we can prevent this in the future, and of course, as I said in the previous slide, address all these: confidentiality, integrity, availability, and authenticity.
Greetings, my name is Ngoc Nguyen, and I'll be going over the methodologies of our Capstone project design. Our design consists of 3 major components. First, there is a backend, which consists of a server, which will be hosting in a database through cloud services. This database will contain 2 tables. The tables will hold, table 1 will hold the user accounts, which contains stuff like usernames, salted passwords, and their groups that they belong to. In table 2 will contain group information. In this table, we will have the information regarding all of the meetings of each group, the members and their membership within each group, as well as the meeting locations and times. Now, this database can be held in a cloud or written in SQL. On the front end, we have 2 clients that compose of our IoT network, and these clients consists of an Android phone application user as well as an Android smartwatch application user. A user on the Android phone application will connect to a single smartwatch via Wi-Fi or Bluetooth, and our primary task is to keep this means of connection and communication secure. a user on the Android smartwatch application will be synced with the server, which will be displaying real-time information of the meetings as well as the GPS location data. Now, that means that the users on the smartphone and the smartwatch will have to be consistently querying and gathering information from the cloud services. Thus, the information that is going through these forms of communications must be secure and confidential. We plan on writing the Android phone application in Java using Android Studio IDE. Next slide, please. To go in depth on our phone application, this is a summary of the main functionalities. We have our application as a project collaboration manager. So as such, we have to support a user creation and authentication process. Once a user is created, they may now create groups. And if they create a group, they are the group leader. Now a user may add groups and invite people to join their group in whatever project they so choose. Once they created a group, the group leader can create a group meeting, which will compose of a brief summary, a meeting location, and a meeting time. Once this is created, the smartphone application will notify the other members of the group. This phone application shall also support location services, such as the GPS of the location, as well as the time of location. If such a time of a meeting style changes, the smartphone must notify the team members of these changes and update respectively to the smartwatch application. And that application must then also update. This is done through communication with the cloud service database. If time allows, we also plan on implementing a messaging/bulletin board. It's kind of a discussion board system where group members may communicate with each other and speak about a current meeting or some thoughts after the meeting. Next slide, please. This comprises the main functionalities of our smartwatch application. The smartwatch will consist of 3 primary faces. In the first face, there will be a summary of the most recent meeting, in which it will be displayed the time and date of the meeting, the location, such as an address of the meeting, as well as any notes and the group name of the meeting, of which the meeting belongs to, if a user belongs into multiple groups. In the second phase, there will be a countdown between the current time and the time of the meeting, so that a user will know exactly how much time they have prior to a meeting. In the third phase, there will be a GPS map, so the user can track their progress towards getting to the meeting. In order to keep this data updated, the smartwatch must communicate a query to the database server securely. The smartwatch shall also support notifications and pop-ups in the event that there are changes in meeting times, as well as reminders from 1 hour to 30 minutes left of a meeting. Next slide, please. This is our initial design of the smartwatch interface. As you can see on the left, this is the initial face where a user can see the most recent meeting. It'll have displayed the date of the meeting, as well as the title, the name of the meeting, and the group in which the meeting belongs to. If a user chooses to swipe to the right, they can see an interactive countdown until the meeting, which will be displayed from days, hours, minutes, to seconds left until the meeting. In order to get this information, the smartwatch must consistently update and query the information from the cloud service. Finally, if a user chooses to swipe to the right again, they can see a map of the location of the meeting. and this will also update as the user makes their progress towards the meeting. And if the user chooses to swipe up and down, they can see the exact same three faces, except for the faces will now be responsible for displaying the information of the next recent meeting, respectively.
So our main focus in this project is this network model, and the entire application process that we've been building up until now is just a test case for this network model. As you can see, these devices are communicating to the cloud. They're using a secure channel, and then the smartwatch also communicates through the phone and the cloud. So a lot of our research that we're going to conduct in upcoming research is going to be what type of protocols we implement. A lot of these IoT devices, they have performance and power constraints and can't use heavyweight encryption protocols. And so we will research lightweight encryption protocols and designs that are suitable for the IoT network. Next slide. And through the server, our database is going to consist of these two tables that we mentioned earlier. It'll have a user accounts table that has usernames, passwords, group membership. And then it'll have for table 2 a group information table with group names, group members, meeting times, dates, GPS location. And a very important thing to note here is that a lot of the information that's being stored is it needs to have taken into account the privacy of the user, especially GPS location, usernames and passwords. And so what we will do in this project is secure this information by hashing and salting passwords and using other secure methods of storing this data. Next. Our team roles is database and cloud server will be done by myself, Emanuel. Smartphone application is going to be done by Ngoc Nguyen. Smartwatch by James Hutchins, and smartphone and smartwatch communications is going to be done by Laurence Chang.
Hi, I'm James Hutchins, and I will be presenting the schedule and what we have accomplished. So initially, by the end of November, we would like to have a research into the implementation done and have started to work on the project. By the beginning of December, we would like to have completed the database, have it set up. We would like to have the smartwatch set up, and we would like to have the smartphone app set up. Between those, we will have simplistic communication. The focus of our project will eventually be securing that communication, but we need a proof of concept to prove that it works before we ruin it with secured system. By the end of December, we would like to begin implementation of this secured system so that we can show that the system can be secured and can be updated to be secured. We will cover each of the security objectives like confidentiality, integrity, and authenticability in the system. Next slide. In the January-February time period, we would like to have all of the proposed functionality implemented. We will have the app implemented on both the smartphone and the smartwatch. We will have the database set up, and we will have the secure communication. The secure communication will include encryption and protocols to make it so that the users can identify each other, and the server knows that one smartphone is this smartphone and not another smartphone pretending to be that smartphone. We will then begin debugging to find any problems with the network. We will begin debugging to find if the encryption is not working, if it's easily crackable. Hopefully we will have found one that is not easily crackable. And then we will write everything up into a report and have that done by the end of February. In March, we will be completing the Capstone project and poster. We will demonstrate our app, and we will give our final presentation. Next slide. So for the project deliverables, we're going to have an IoT service, which will include a smartphone, smartwatch, which is our IoT device, and server. The server will host a database basically that will hold all these information securely for the app. The IoT client itself for the smartphone and smartwatch will be able to access all the information, and the end user should not see any differences, but we will have secured communication between the smartwatch, the smartphone, and the servers. We will complete the Capstone report and the Capstone paper, and we will complete our demonstration. Next slide. So far, we have gone through several iterations of designing the initial proposal, as our mentor has wanted us to come up with a clear, defined path before moving on. We have begun research into the server, smartphone, and smartwatch, and we've assigned project responsibilities. The initial IoT network design tests will begin soon, and we will hopefully finish up shortly after. Next slide. These are our references for our research, and that's it.